Okay, students, so today's objective is we are learning how to factor polynomials, and specifically we are going to factor cubic functions. And we are going to do this using the factoring patterns of the sum and difference of two cubes. So today's factoring lesson will only be on sum and difference of two cubes. So let's review what a perfect cube is before we move on. So here are some perfect cubes. 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is 8. 2 times 2 is 4 times 2 is 8. And here's some other ones. 3 cubed is 27. 5 cubed, 125. And we can work our way down to 10 cubed, which is 1,000. So put these in your notes, but these are good ones to memorize. You will see 6 cubed come up a lot, 7 cubed, so if you recognize that these are cubes, it will help you. Okay, what if we have variables now? Well, x cubed, this is a perfect cube. So is 8x cubed, because 8 is a perfect cube, and so is x cubed, so the combination are perfect cubes. So 8 can be rewritten as 2 cubed, x cubed, so this is the power of a power function, so if we write this, we can write it in parentheses, and you can see how it's a perfect cube, because inside the parentheses, this is a perfect cube. So we want to write cubes as a power with a base and an exponent, and the exponent is going to be 3 for all of these cases. X to the 6. Now again, like this might not look like a perfect cube, but can we rewrite this as something cubed? And the answer is yes. We can rewrite this as x squared, and remember, if we have a power on the outside of a power, we multiply these. So since I can factor 3 out of this, this is a perfect cube as well. Okay, so let's see how well you guys can identify cubes. Are these cubes 27x cubed and 9x cubed? Are these perfect cubes? Well, let's look at this one first. 27x cubed. Oh, sorry, we have one more. X to the 9th. So are these perfect cubes? The first one, 27x cubed. Yes, this is a perfect cube. And if you look at it, it's because 27 is a perfect cube and x cubed is a perfect cube. So I can rewrite this as 3 cubed. And then I get the 3x. If you multiply that by itself 3 times, you get 27x cubed. Okay, this one's not. Why is this one not a perfect cube? X cubed is a perfect cube. But look at 9. 9 looks like a perfect cube, but it's not. 3 times 3 is 9, so 3 squared is equal to 9, not 3 cubed. And x to the 9th, this one is a perfect cube, because I can rewrite this as x cubed cubed. Okay, recognizing a difference or sum of two cubes. Now, difference. This word is a fancy way of saying subtraction. So since I have a subtraction and both of these are perfect cubes, this is the difference of two cubes. Sum of two cubes, well, I have an addition sign, so it's the sum of two cubes. And note that both of these are binomials, so the polynomial that we have are binomials. They're both have two terms, one term, two term. And both terms are cubes, so that's the requirement. We have to have two terms, and they both have to be perfect cubes. And if it's a difference of two cubes. If it's an addition sign, it's a sum. Okay, here's some examples. of differences in sums of cubes. 64, this is a perfect cube. This is 4x cubed minus 5y cubed. And this one, this is another example. Let's look at y. Well, we can rewrite this one. This is a perfect cube, and we have the difference, perfect cube, so this is a difference of two cubes. And this one is a sum. Let's go back to that. This one is a sum of two cubes. Okay, now I'd like for you to try. Let's look at some non-examples first, and then we'll have you try. So if we have 72x cubed minus y cubed, and x cubed plus x squared, well, the first one, 72 is not a cube. There's no three numbers that multiply by each other equal 72, or no three integers, I should say. So this is not a cube, so therefore it doesn't pass. This one, x squared, well, that should jump out. This also is not a cube, so this one doesn't work. Okay, this is your turn now. Classify the following as either difference of cubes, sum of cubes, or neither. So here are our options down below. So let's take a look at this one first. 3x cubed minus 5x squared plus 2. There's that 3 there. I have 3 terms. What do you think? Hopefully you said neither. The big thing is there are 3 terms here, so it's a trinomial. So right away I know that it's neither. And also I have this x squared term in here. And 2 is not a perfect cube. What about this one? 27y cubed plus x cubed. This one goes in sum of cubes. We have this plus, these are both perfect cubes. What about this one? 8 is a perfect cube, but x squared, right there, that tells me it's a neither. I see this square right here, so it doesn't work. Down here, I got the x cubed and the y cubed and a difference. However, wait a minute, 2 is not a perfect cube. That's neither. Neither is 4. Now, a cubed minus 1. This is a perfect cube. And here's a tricky one, but this is a perfect cube, because 1 times 1 times 1 is 1. So I look at this, it's a difference, so there's my first difference of cubes. And here it's written in a different order, but we have a perfect cube plus a perfect cube, therefore that's a sum of cubes. Okay, now remember our objective is to factor these. It's an important objective so that we can solve sum and differences of cubes. So we're going to use SOFAs to remember the factoring pattern. SOFAs is an acronym. So let's look at what it stands for. Okay, so we have the difference of two cubes and the sum of two cubes. Both use SOFAs. So what the S stands for is square the first term. Okay, now this is a pattern. So if you look up here, let's look at the difference. We have a cubed minus b cubed. Well, I'm factoring, so I'm going to write 2 sets of parentheses. Notice I have a binomial and I have a trinomial. My binomial is always going to be to the first degree, each variable. So I take my a and my b and I just write it as a binomial first degree. Now the second one, this is a trinomial and it's to the second degree. So the S in SOFAs, square the first term. So this tells you how to create this trinomial. I'm squaring my first term. My first term is a, so I have a squared. Now O stands for opposite sign. That's this sign right here. Well, since I have a difference, a cubed minus b cubed, I put an a minus b. We start off with this difference. And now my first sign is opposite. Since this is a negative, this becomes a positive. Look over here on the sum. Since this is a positive, this first one becomes a negative. Opposite sign. Now we're at F. F stands for first term times the second term. So here's my first term, here's my second term. So the F, this is how I build this middle term. My first term is A, my second term is B, so I have A times B. Now we're at A. A is for always positive. Notice that this sign is always positive. So my last sign in my trinomial is always positive. And the last one, S, this stands for square the second term. So here's my second term, and I'm squaring it. Here's my second term, and I'm squaring it. Okay, let's look at an example here. So notice that this pattern, it sets up what numbers I plug into. So the first thing is recognize as a difference or a sum of cubes and identify A and B. So this one was a difference of cubes. And then I'm going to substitute my values into the factoring pattern and simplify. Now let's look at an example of this. I have 27x cubed minus 8. Recognize it as a sum or a difference. Well, this is a perfect cube, this is a perfect cube, and this is a perfect cube. So we have a difference of cubes. Identify my A and my B. So in order to do this, I need to write as a perfect cube cubed. So inside here I have 3x cubed minus 2 cubed. Therefore my A term, this is my A term, and this is my B term. My A here is baby blue, and my B term is purple. Now here's the pattern, and the pattern I set up using SOFAs. This is my A minus B because it's a difference, and then the SOFA, S, square the first term. That's why it's baby blue. Square the first term. Opposite sign. First term times the second term. First term times the second term. Always positive. Square the second term. Now I'm just going to take my A's and I'm going to fill them in to each baby blue spot. My B's are going to go into each purple spot. Now that I have this, I just need to simplify. So this is the key thing here. You need to simplify your squares, but note that in this case, this whole term, 3x, is getting squared. So when I simplify, since this whole 3x is getting squared, that's 3 squared is 9, x squared. And over here I have 2 squared, which is 4. In the middle I have 2 times 3, which is 6x. So this is my factored version of my difference of 2 cubes. Okay, so there will be more practice problems. I hope you guys understood that example. SOFAs takes a bit of memorization, but with a bit of practice, it's not a hard objective. Remember to raise your hand if you have any questions, even during this video. During all videos, you can raise your hand, and we'll work through a lot of example problems until you guys feel comfortable with sum and difference of cubes, factoring sum and difference of cubes.